Welcome back to the GCSE Maths Pro YouTube channel. Today we're going through the third and final paper from the June 2023 series. So we've got paper 3, obviously higher tier. This is Edexcel and you will need your scientific calculator to go through this one. So getting straight into it, we've got a series of 1 markers. First of all, they've said simplify m squared and then all of that cubed. So this is just straight into index laws. When we have the brackets, it's when we multiply the powers. Okay, so you've got m as your base number still, and then 2 times 3 is 6. M to the power of 6. Literally as straightforward as that. The reason why they've used m and not a number is because they're trying to get you to do it non-calculator, if that makes sense. So you can't just type it in. Same with the next one, so simplify x to the power of 5 times x to the power of 8. Now this one has the multiply symbol, and you can see we've got x to the power of something and then another x to the power of something else. That's the one where we have to add the powers, okay? So obviously x is still the base, and then we do 5 plus 8, which is 13. Okay, so hopefully you can see the difference between part A and part B, how those index laws are different. Part C is no longer really index laws, as it's effectively just expanding. So expanding a single bracket, we're just going to multiply everything by 4p. So first of all, 4p times p squared, that would give us 4p cubed, and then 4p times 3p, obviously it's plus, they're both positive, and then 4 times 3 is obviously 12, p times p is p squared. So that's all you need to do for question 1. So question 2, Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. And Johnny is going to assume that 68% of the people will drink coffee. So not everyone in the meeting is going to drink the coffee. He thinks that only 68% of the people will drink the coffee. So using this assumption, work out the amount of coffee that Johnny needs. So first of all, my thought is, okay, well, let's just work out actually how many people are going to be drinking coffee in the first place, because it's not all 800. So I want to work out 68% of 800, which on a calculator paper, I just multiply 800 by 68%, but as a decimal. So you just divide by 100. So that would be 0.68. So I would just literally type that into my calculator. So 800 multiplied by 0.68 is 544 people. So that's how many people we think are going to actually drink the coffee. Then if we come back to this middle bit here, they said that, okay, of each person who does want to drink coffee, they're going to be drinking 2 cups each. So you could do 544 multiplied by 2, so that's how many cups you'll need. And then I would probably just do it in the same step. Each cup of coffee is 10.6 grams, so I would just multiply that as well. You can do it separately in 2 different steps if you want. I'm just going to multiply everything together. So we want 544 times 2 times 10.6. I've just used my answer button there to copy the 544. And then we get 11,532.8. Now that's how many grams we need, but just double check, they've asked us to give our answer correct to the nearest gram, so I'm obviously going to have to round that up. So 11,533 grams is what that would round to. Okay, so that's part A. Quite a nice question for 4 marks, that. Now we've also got part B down here, if I just scroll down a bit. Bring this up. So part B, Johnny's assumption is wrong. So actually, if you remember, they were saying that he's assuming that 68% of people will drink coffee. So that was just an assumption. So his assumption is wrong. It's actually 72% of people will drink coffee. How does that affect our answer to part A? We've got 1 mark. I know they put 3 lines. You don't have to fill the 3 lines, right? We just want something really straightforward. When it's a worded answer, because it's maths, it needs to be just something really basic. Doesn't even need to be a full sentence, okay? So how does that affect our answer? What's the most obvious thing to say? Well, we assumed 68%. It's now actually 72%. So how will that affect how much coffee he needs? he obviously will need more coffee, won't he? So that's literally all I would say. He will need more coffee, or some version of that, right? As long as you're just saying there's more coffee, then that's enough. Okay, he will need more coffee. Okay, question 3. So we've got ACF and ADG are straight lines. So ACF, AD, so these are those ones here, the diagonal ones. And then they've said BCD and EFG are parallel, which you can see with these little arrows. That means that these are parallel. So I'm thinking we're obviously going with parallel angles and parallel lines here. So show that triangle ACD to the top triangle is isosceles and give a reason for each stage of your working. Okay, so an isosceles triangle is obviously one where 2 of the angles are the same, isn't it? So looking at this, we can't obviously tell which 2 are the same, but we're just going to have to work out all 3 angles and hope that 2 of them end up being the same. That's what we're saying here. So I think the easiest one to start with is the 110 because it's right there. I could work out ADC, couldn't I? Because that's just on a straight line. So write down which angle it is, ADC. And I would work that out by doing 100 minus 110. Because it's obviously 180 minus 110, which is obviously on a straight line. Okay. So that is 70. Now they've said give a reason for each stage you're working. So you would write down, I mean, again, not even a full sentence, but just angles on a straight line. Just going to bring it over here. You can say add up to 180. I just put equals, 'cause a bit easier. Equal 180, don't they? Okay, the next one. We want to work out either the C angle or the A angle, whichever we can figure out first. I think C is the next one. We've already used 110, so the other thing we haven't used is 125. Okay, so how can I relate 125 up here? There's actually multiple ways to do this one. Loads of different ways. The way that I was going to do it is I would work out BCF, and then it would just be like opposite, wouldn't it? So, BCF is 180 minus 125 because these are co-interior angles, or you might have learnt them as just interior angles. So that is 55 there. And I would say or whatever your reason is, I know it is co-interior angles. And they also add up to 180, don't they? So put equals 180. Okay. So that's 55. And then, therefore, this angle inside the triangle is also 55. So I would literally write that. I think they also allow it if you've labelled the diagram clearly, but I also like to write it down just to be really obvious. So that's ACD, isn't it? Is 55. And that one is because I know it as vertically opposite angles. I think just opposite angles might be okay. And these ones are the same, aren't they? Or are equal, however you want to write that. Okay, now that we've worked out these 2 angles, I can obviously work out the third and final angle because it's in a triangle, isn't it? So that top angle would be CAD. See if I need to move this up a little bit so that you can see. Would be, obviously, angles in a triangle add up to 180, so that's another 180 minus both of the others. So I would do 70 plus 55. And that actually does give us another 55, which is what we were hoping for. And you would just write there, angles in a triangle. And those ones add up to 180 as well, don't they? So you can see that we've got 2 angles, if I label that again. Saying, show that the triangle ACD is isosceles. Well, I think that's just implied because you've worked out that both of them are the same. So I would probably, I don't think you even need to do this, but I would just put therefore isosceles. Just as like a mini conclusion. Okay, that's literally all I would do for that one. But we do need to know the angles, the reasons for it, because I think that's probably about 2 marks of your answer is for the reasons. So you obviously don't want to miss that out. Okay, so question 4, it takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take 4 of these pumps to fill another water tank of the same size? So I don't know if you recognize this, but the topic is effectively inverse proportion, but in a worded context. You know, it's not y is inversely proportional to x. It's not as obvious as that, but it is the same logic, because if you think about it, if I were to have more taps, or what is it, pumps, more pumps filling up the same water tank, it would take less time. Do you see how that's inverse? More pumps, less time. If I had fewer pumps, it would take more time, wouldn't it? So it's like opposite, it's inverse. So I think this is why a lot of people get stumped with this one, because naturally I feel like you want to, obviously we want to work out how long it takes for one pump to fill the tank, but I think people naturally would try and divide. But that would only work if it was directly proportional. It's not, it's inverse. So what I'm saying is, to work out one pump, how long would it take, how many hours would it take for one pump to fill a water tank? Well, it would take 5 times as long, wouldn't it? 5 times longer, because I have obviously 5 times less pumps. So, times by 5. So you would, I think naturally there you'd want to divide it, wouldn't you? But it's not, because it's inverse. Just remember, okay, if I've got something like this, sometimes they use the context of like painters painting, how many hours does it take 5 painters to paint a wall, or builders, you know, like, and taps to fill a swimming pool, things like that. It's all different contexts, but you can kind of pick out that it's the same topic. So multiply that, we should get, if I get my calculator, 14 times 5 is 70. Okay, so 70 hours, obviously that's longer than the 14, isn't it? It's 5 times as long. So that's 70 hours for one pump. Then we can look at the number of pumps they actually have. Okay, they've said, how many hours would it take for 4 pumps? So it's 4 of the same pumps. So you would then do, now you would divide. Because I think naturally now you want to multiply, you actually do the opposite, you do the inverse. Now we divide 70 divided by 4, because it should be 4 times faster. So less time than just one pump. So if we divide that, 70 divided by 4 gives us 17.5. Okay, that's for 4 pumps. That's your answer there. You can see it's 2 marks because effectively you've got 2 steps. Sometimes there's also a part B. We don't have it here. Sometimes the part B is, what assumption have you made with this calculation? And you'll always say something to do with, obviously related to the context, but something to do with the fact that in this case, that all the pumps, well, they've obviously told us they're identical, but if there was an assumption, you'd say that all the pumps fill the tank at the same rate. It's always something to do with the same rate. So let's say if it was painters, you would say, we've assumed that all of the painters that they paint at the same rate. All of the builders build at the same rate, something like that, if there's that part B. Okay, question 5. A and B are numbers such that we've got A is 2 squared times 3 to the power 4 times 7, and B is 3 squared times 7 squared. First of all, find the highest common factor of A and B. So, different ways to do this, but I like to use the Venn diagram method. So I'm going to draw. You can obviously just roughly sketch it, but I'm just going to get some circles. Oh, it's massive. Okay. There. Hopefully I've got enough room there. Okay, and then I would just label like A and then B. So the middle bit we always do first, it overlaps. Now if you find it helpful, you can list these out so it's not in index form. So for example, A is 2, 2, 3, 3, 3, 3, 7, and B is 3, 3, 7, 7. You can always list it like that, and then you can tick them off. So whatever they have in common goes in the middle. So see how they both got a pair of 3s here and here? So that goes in once. That represents both of those, okay? Then they've got another pair. So that goes in. And then the only other thing they have is they both have 1 7 there. So 1 7 goes in the middle. And then whatever's left goes in the left and the right hand side. So A is 2 and 2 again, and then 3, 3 again. And B is just a 7. Now, highest common factor
is just the middle bit multiplied together. So technically you don't need to fill out the rest of that Venn diagram. The only reason why I did is because I know that part B is then the other part that I need. So I filled out the whole thing. So highest common factor, I know the word highest is in it, but it's actually the smaller number because you're looking at the word factor. A factor is something that divides into a number, so it's a smaller number than the original, isn't it? So we would do 3 times 3 times 7, times 7, which obviously you could probably work out yourself, but you can always also use the calculator. 3 times 3 times 7 is 63. Okay, that's the highest common factor. Now they have said then find the lowest common multiple, so that's why I drew the whole of my Venn diagram, because the lowest common multiple is everything. Okay, the whole Venn diagram, so that's highest common factor. And then if I do a different color, lowest common multiple is all of that. Okay, I don't know if that's very clear there, the overlap. So LCM would be 2 times 2, just make sure you don't miss any, because it's quite a few, times 3, times another 3, times 3 again, times 7, and another 7. And then you would type that obviously into your calculator. So let's get that. 2 times 2 times 4 3s. 3, yeah, and then 2 7s. Okay, make sure I've got that right. Yeah, so we've got 15,876. And again, you might be thinking, well, the word lowest, it must be a small number. No, the key word here is multiple. Multiple is the times table. So they're always, apart from 1 times itself, they're always bigger than the original numbers, aren't they? So you are going to get quite a big number for lowest common multiple. Okay, that's how I would just do it, just draw the Venn diagrams. Okay, question 6. So lava flows from a volcano at a constant rate of 11.9 meters cubed per second. This is the key thing in this question. Second. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? Give your answer correct to the nearest day. So initially I was thinking, well, this seems like not enough working for 3 marks, but then I realized this S is seconds and the obviously days. So it's not just working out the rate in terms of using a rate, it's also then converting from seconds to days. That's why it's 3 marks. So what I did first, what I would do is I would just first of all divide these two. Okay, so what I mean by that is how many seconds would it take to for this amount of lava to flow from the volcano? So that would be 67 million. There, make sure we don't get any of it wrong. Divided by 11.9. Because that would tell me, because obviously you see how the lava is in meters cubed. Both of those are already in meters cubed, so that unit is fine. That would tell me how many seconds it would take for that amount of lava to flow. And then afterwards I can convert into days. So 67,205,600 over 11.9 is all of this number. So let's just write, I'm going to write all of that down even with the decimals, okay? 5647529.412. Okay, that's how many seconds it would take, because the rate was in terms of meters cubed per second. Now I just need to convert this into days. So I would work out, well, how many seconds are in a day. There's 60 seconds in a minute, there are 60 minutes in an hour, and there are 24 hours in a day. So we effectively need to divide by that. But I'll just work it out separately so you can see. So there are 86,400 seconds in a day. And then we just divide these two answers. That will convert it into days. Sure I've not missed any digits there. And then divide by 86,400. 5, 6, 4, 7, 5, 2, 9. Oh no. That's a 6, isn't it? 5647. Make sure you obviously type it in right. 0.412. I'm not going to round it too soon. 86,400. Is that right? Yes. Okay, and then I get this 65.36. Now the only other thing though is that they did say to give our answer correct to the nearest day. At the end of every question I kind of go back once I've done my working out and just double check if there's any formatting. So that would be 65 days. It would round down because of the 3. Okay, that's what I would do for that one. Okay, question 7. This is actually a really nice one, 2 marks. So here is the graph of y equals x squared minus 2x minus 2. That's obviously a quadratic graph. First of all, write down the coordinates of the turning point of the same graph. The turning point is obviously where it changes direction. So you see how that would be here? It's gone down and then it changes and goes up. So that's obviously 1 minus 3. Write down an estimate for one of the roots of this equation here. Okay, this is the bit where I feel like some people don't really know what it means, but it's really straightforward. So first of all, roots is another word for solutions, which in terms of this equation means what is x. And there's multiple, right? Because they've put s at the end, it's a plural. So we're going to have more than one solution, which if you think about just quadratic equations generally, you always get 2 answers, don't you? So that's what it means. There's going to be 2 answers. But we need to know, well, yeah, but where are we referring to? So this is where I say compare. I get my highlighter. The original up here, do you see this? X squared minus 2x minus 2 is the same as this side. And then do you see how where originally it said y has now been changed to 0? I know it's been flipped, but that doesn't really matter. That bit there used to be y, didn't it? That used to be y. So what we're saying is, it says when y is equal to 0. That's when we're looking for our solutions. That's also why we don't need to know what y is, because it is 0, isn't it? We don't need to write down y as a solution. The solution is just for x. So what that means is you go onto your graph and you say, where is the line y equals 0? Well, that's obviously here, isn't it? That's the x-axis effectively. So in this case, it's saying, look at where our quadratic crosses the x-axis. Obviously, it's going to be 2 solutions. It crosses twice. So you can obviously look in yours. They do give a slight range of possible answers just because this isn't exact, isn't it? When I looked at it, I kind of thought, well, this one over here, I put 2.7 for that one. Just be careful of the scale. If I get rid of that, can you see the scale is there's only 5 squares, so it's like 2.2 is 1 square, then 2.4 is the next square, 2.6, and then 2.8, and it's like in between. So you only need to do it to 1 decimal place, right? So I did let me give myself more space. X is 2.7 for that one. And then I looked at this other one and went, okay, that's, just be careful with the negative. It is a negative. Sometimes we forget it's a negative. Negative 0.2, 0.4, 0.6, and then it's in between 0.6 and 0.8. So normally they're kind of the same decimal, so I put negative 0.7. And those are my 2 solutions. That's literally the answer. Okay, you can see they've not given you any space for working out. It's only 1 mark, so there would be there's nothing to work out really, is it? It's just looking at the graph. They've also said write down. When they say write down, it means the answer is here somewhere already. We just need to find it. It's not a calculation as such. Okay. If the number here is not 0, because sometimes they change it, it could be like 2, for example, you would obviously look at the line, y is 2. Okay, just check what number it is, and then that's the line that you're going to look at. Okay, that's literally all it is. Super easy. All right, before we go on, I'm just going to tell you what the range was. So they've said they will accept answers between 2.6 and 2.8. So if you said 2.6, 2.7, 2.8, or if you put, some people might have put 2.75, that's fine. And obviously then the same with the negative ones, is negative 0.6 and negative 0.8. That's the range. So as long as you've got one of your answers are both between those ranges, then you've got the mark. Okay, question 8. So a solid cuboid is made of metal. The metal has a density of 9 grams per centimeter cubed, and the volume of the cuboid is 72 centimeters cubed. work out the mass. So this is obviously density, mass, and volume. This is a formula you do need to memorize. Okay, it's not on the formula sheet, they don't give it to you. The one they do give is pressure, force, area, okay? So I normally remember the formula triangle just so I can rearrange it. It's always mass at the top, and then density and volume. It doesn't really matter which way around you put them. So in this case, because we're looking for mass, if I cross that one out, do you see how I'd have to just multiply density and volume? Mass is density times volume. Now, before you do anything, just double check that the units do match. So in this case, you see how they've got density is grams per centimetre cubed, and then the volume is centimetres cubed. Just make sure those do match, otherwise you'd have to convert. In this case, they match. It's only 2 marks. It's quite straightforward. I literally just have to multiply 9 times 72. Okay, that's it. So calculator, 9 times 72, 648. That's your answer. It's literally as straightforward as that, as long as you don't have to change any units to make them the same. Okay, question 9, if we scroll. Question 9. Some people were asked if they wanted a new television. 70% of the people said yes. And then 80% of the people who said yes, so within this 70%, there was another 80% of those, wanted a television with a large screen. What percentage of the people asked originally said they wanted a television, but also with a large screen? So it's like a percentage within a percentage. It's 80% of the 70%. So the way that I would work this out, especially it's calculator paper, is I would take 70 just as a number, and then I would multiply it by obviously 80%, which is 0.8 as a decimal. And if you do that, 70 times 0.8, 0.8 gives you 56. So it's 56% of the original. Because originally, let's say, I know you don't have any numbers for who there were originally, but I normally, if I don't have any numbers, I normally work with 100. Do you see how, like, if I would say, right, what's 70% of that? That would be 70. And then what's 80% of 70? That's 56. So it's 56 out of the original 100. Okay, so hopefully that makes sense. It's a percentage inside another percentage. Okay, question 10. ABD is a triangle. C is a point on BD, and they've said work out the length of DC, this one here. So normally here when we have two triangles stuck together, it's because there's not enough information about the triangle that we actually want. We obviously want DC. You have to use the other one first. And in that case, normally, so most of the time, it's helpful to work out the line that joins both triangles, because that's the only thing they have in common, isn't it? So looking at the right-hand side, I'm going to work out AC first, and then it will give me enough information about the left-hand triangle to work out DC. So it's kind of 2 steps. So first of all, to work out AC, this is obviously trigonometry, isn't it? SOHCAHTOA, because we've got right-angled triangles, we've got some sides and some angles. So I need to label the 2 sides that are relevant. In this case, AC is relevant because I want to know what that is. That's the opposite of the angle 41. And then AB is relevant because I've been given it, which is the hypotenuse. So you see how that gives me, I need to use sin, which is in my triangle, SOH, so, from SOHCAHTOA. And then I cross out the one I want. So because I want the opposite, do you see how my calculation is multiplying both? So that would be AC, which is the one that I want, equals sin, and the angle always goes with sin, doesn't it, or cos or tan. So sin of 41 multiplied by the hypotenuse, which is just 6.8. That's what I'm going to type into my calculator. So, sin, and just normal sin, not inverse, because we have got the angle, just a normal sin. 41 times 6.8. Now, you obviously get loads of decimals. I'm going to leave that in my calculator, but I'll write down a couple of them, so like 4.46 maybe. Dot, 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 isn't it? Because I know that there's technically more decimals. And I don't want to round it now because we're only halfway through the working. So I always try and leave my rounding until the end. So now that I know this top one here, so let's say that's 4.46, I can now look at the triangle on the left. So now I want to work out DC. Let's label that again. In terms of this triangle, the 2 sides that are relevant is obviously the 4.46, which is also the opposite.
But this time I want to know DC, which is the adjacent. So do you see how, because that's O and A, make that a bit bigger, I would need tan or TOA. And in my formula triangle, in terms of SOHCAHTOA, you always put the middle letter in the top of the triangle, so that's quite easy to remember. I'm trying to work out A, so cross that one out. You see how in this case, to work out DC, which is the adjacent, I would have to do the opposite, which is the 4.46 ... number, over tan this time. Don't forget we're now swapping to tan. 55 degrees. That's now what's going in my calculator. But as I said before, I've got loads of decimals here, so I'm going to use, you know, when you use the ANS button, the answer button, because I'm not just going to put 4.46, I'm going to copy all of the decimals. So if I put my fraction, if I put answer, that's the 4.46 ... and then tan, again, normal tan, because I've got the angle. There's my answer. Now this is now the final answer, so I can actually round this. So if you have a look, it says give your answer correct to 1 decimal place. That's fine. I just need to round it to 3.1. Okay, 3.1 centimeters. That would be a final answer. So if I scroll down, you can see 3 marks. 3.1. So I try not to round anything until right at the end if I can avoid it. Okay, question 11. We now have box plots. So the table shows some information about the heights of a group of adults. I highlight that. You see adults. On the grid, draw a box plot for the information in the table. So this one is for adults. So this is really easy actually. When I look at the table, I know that a box plot has 5 vertical lines, as you can see here. In the second one, 1, 2, 3, 4, 5. And just checking my table, it is all of these, isn't it? You need the least or the minimum, you need the greatest or the maximum, you need a median, lower quartile, upper quartile. So that's all perfect. I just need to translate that onto my box plot. Now, do really be careful though, because the scale of this box plot is kind of interesting. I think that's how they make it harder. The actual copying numbers across onto a grid is really easy. It's more so just double check the scale, because in this case, you see how the difference is 5 in terms of 155 and 160 is 5 centimeters, but it counts 10 squares. So like every one is 2 squares. So that'd be 156, 157, 158, 159. So just be careful with that, because it's not normal to have 2 squares per one, in this case 1 centimeter. But otherwise, we just need to get our ruler. Get your pencil and your ruler. I'm trying to grab my straight line. See if I can make it a bit smaller. And then you're just going to draw vertical lines, literally on all of these. So I'm just going to go in the order that they've listed it. 169 would be 2 squares before 170, because I feel like naturally you'd want to put it at 1 square before, but because the scale is different, you need to not do that, obviously. So it doesn't really matter how big your lines are, to be honest. There, that would be 169, wouldn't it? Then 186 is up here. And get it straight as you can. Obviously, in real life, you'll be able to do it much more easily than I can. 177, so that would be 4 squares along from 175, wouldn't it? There. And then 174, which is 2 squares before 175. And finally, 180 is, luckily that's just on 180, isn't it? And then the middle 3, you can obviously copy kind of the one below. The middle 3 join up to create a box. Because those are the key pieces of information, aren't they? Let me do that a bit lower. And then the other 2, you just join as kind of like, sometimes they call it a box and whiskers. These kind of whisker things. There, mine's a bit wonky, but obviously yours will look better than that. So that is 3 marks, literally just translating across those 5 lines. Then we've got part B. So if I scroll down, part B says, so here we've now got the box plot below shows the distribution of heights of a group of teenagers. So see how the first one that we did was adults? This is now referring to teenagers. And then it says, compare the distribution of the heights of the adults with the distribution of the heights of the teenagers. 2 marks. Now this is actually really easy. It's a worded question, which
Normally those I feel like are harder, but it's easy because the answer is always the same. So you just have to memorize the 2 things they want you to mention, because you see how it's 2 marks? They want you to mention 2 things. And it's always the same, so that's good. The first one, you need to mention the medians. And when it says compare, we're not explaining why. We're just literally comparing which one's bigger, which one's smaller. That's literally what I do. So I would say, the first thing I would say is about the median. And you would just compare, like, see if you can read off what the medians are. So the median height, try and relate it to the context. In this case, it's heights. So I'd say median height of adults, and then you just say if it's bigger or smaller. Adults. Sometimes I write the numbers, so I might just put in brackets the numbers here. So the adults was this top one, wasn't it? Which, I mean, it's on the table, but it was 177. 177 is, and then you just compare it. See how this line in the middle is the median, isn't it? That's 169, isn't it? In the teenagers. So is bigger, is higher, is greater, whatever you want to call it, than, and then you say the median height of the teenagers. It's literally like, it feels too obvious, but that is literally it. Well, that's the first mark anyway. Teenagers, and then I would probably just put in brackets what the teenagers one is, so you can see that you've read it off. And then number 2, you have to put both of these to get both marks, is then, because the median is like a single point, effectively, isn't it? A single number. And they've asked for distribution, which is kind of like spread, isn't it? How it's spread out. You can mention, you've got 2 options here. You can either mention the interquartile range or the actual range. I normally do the interquartile range, but they will accept both. So I would say the interquartile range. So again, just compare it. Obviously, you could work it out. What is the interquartile range? So this one was 174. Again, be careful with the scale. And that was 180. So that interquartile range is 6, isn't it? And then the one here is 165 to 1. That's 171 there, isn't it? That's also 6. They've actually got the same interquartile range, and that's what you would say. So interquartile range of heights, probably don't even need to write that, of the adults, is the same, or I think you could say it's similar, but I'm going to write the same as the interquartile range of teenagers. And then in brackets I would put 6, just to show that I've worked it out. So I don't know if you can see all of that. Let me scroll up a bit. That's what you need to write. So if you ever get this question, it's always the same. Just compare the median, compare the interquartile range. Because you've got the median as one kind of single point, and then you've got the interquartile range, which is showing a range, effectively a spread. Okay, so that's literally all you need to do. Mention those 2 things, and you'll get the marks. Okay, question 12. This is a nice one. We've just got expanding brackets. So show that x minus 1 multiplied by x plus 3 multiplied by x minus 5 can be written in the form ax cubed plus bx squared plus cx plus d, which is effectively a cubic expression, where a, b, c, and d are obviously integers. So the way that I expand this is I just pick 2 to start with, and then I expand that, and then bring the last one in the end. So I just do the first 2. You can do whichever order you want, though. Doesn't really matter. So x minus 1, and then multiply by x plus 3. This is just double brackets. So x squared plus 3x. Be careful with your negatives. That's minus x, and then minus 3. And then obviously simplify this. You see the middle bit would simplify. So I'm going to write it down here, give myself some space. 3 plus minus x is obviously 3x plus minus x is just plus 2x minus 3. So that's that bit. And then if I put that in brackets and then bring back my last one, which was x minus 5. Obviously, the first one we had 4 multiplications. This one we're going to end up with 6. Okay, so you need to multiply each term from the first bracket with each term in the second bracket. So the way I do that is, obviously, x squared times x, which is x cubed. And then I go x squared again by the second term, just so I know I've completed the x squared fully, which would be minus 5x squared. I do it in this order because then you end up with all the like terms next to each other, so I find that handy. Then I would move on to the 2x, because I've done x squared, haven't I? 2x by x, which is 2x squared. See how now I've got the x squareds together, so it's a bit easier. And then obviously 2x by the other one, which is minus 5. So that's minus 10x. Now we're moving on to our x terms. Then I can move on to minus 3. Minus 3 times x, again, be careful with negatives, is minus 3x. You see how both of the x terms are together now? And then minus 3 times minus 5, that's a double negative, plus 15. So see how the order that I did it in, it doesn't really matter, but it's a bit simpler because you've got everything in size order effectively, haven't you, in terms of the x's. So now the last thing is obviously then to simplify that, collect the like terms. So you see how those would go together, and then these would go together. So we get x cubed, minus 5 plus 2 is minus 3, x squared. Minus 10 minus 3 is minus 13x, and then obviously the 15. Don't be thrown off by the fact that they put all positives, because technically A, B, C, D could be negative in themselves. So don't worry, it doesn't have to be the same symbols they've given you. And also, obviously, in front of the x cubed is technically a 1, so don't worry that there's not actually a number written there. Okay, that's how you expand triple brackets. That's literally all it's asking. Okay, question 13. We've got algebraic proof. So, an expression for the nth term of the sequence of triangular numbers is n multiplied by n plus 1 over 2. Prove that the sum of any two consecutive triangular numbers is a square number. Okay, I feel like a lot of people look at this and go, yeah, immediately I've got absolutely no idea what you're talking about. But algebraic proof, this is algebraic proof, right? Because it's proof and then algebra, is actually quite straightforward when you figure out. I've also got a video on this, so you can check in the description to find that video in the end of this. At the end of this, I just break it down into steps. So let me see if I can get my highlighter. The thing that's probably throwing us off is the triangular numbers, but we'll deal with that in a minute. That is the bit that's a bit harder. What do they want? So what's our starting point? It's any two consecutive triangular numbers. Don't worry about what you're proving, just worry about what am I starting with. So you can't just choose two numbers, actual numbers, right? Because they want any, prove that it works in any case, which means we need to use algebra. So they've said an expression for the nth term of a sequence of triangular numbers is that. So I would use what they've given us as one of those terms. Let me write that right. Yeah, n brackets n plus 1 over 2. Let's say that's my first triangular number. My second triangular number, this is the bit I think is kind of complicated, because it has to be consecutive. N represents any number that the number of the terms, so term number 1, term number 2, and so on. So the consecutive term, if I've got n, the next one, do you see it would have to be n plus 1? Because that's consecutive, isn't it? And then where here it already said n plus 1, that would be like n plus 1 plus 1, wouldn't it? So that's n plus 2. This one I think is particularly hard, to be fair. It's just, once you've got the starting point, then it's really easy. So that's the first bit. Any two consecutive triangular numbers, just take what they've given you and then find a consecutive one. You can also do n minus 1, so consecutive but like before n if you want, but I never really think to do that. Then I think, what do you want me to do with these? This is my starting point, but what am I doing with that? They've said the sum. Normally it's either the sum or the product or the square or something. Sum is obviously plus, isn't it? Add. So what I actually need to do is add these together. Again, I'm still not worrying about what I'm proving. Don't worry about the square number bit until right at the end. So at this point, now I've got my starting point, I know I need to add them. I'm just going to actually do that. I'm going to expand the brackets, I'm going to add them together. Luckily they have the same denominator. So expand the brackets. Algebraic proof is a lot of expanding brackets and factorising. So expand the brackets, because what else am I going to do? Is n squared plus n over 2 plus n squared plus, I'm just going to do this all in one, so that would be 2n plus n, so that's 3n, isn't it, in the middle, if I were to simplify it, plus 2 over 2. They have the same denominator, so do you see how I could actually just directly add the numerators? So I'm going to collect the like terms. I've got 2n squared plus 4n plus 2 over 2. Now this is probably where you're thinking, well, that's looking good because it's all divisible by 2. So I'm actually going to divide everything by 2 to get rid of the fractions. That's n squared plus 2n plus 1. Now that we've kind of expanded, simplified, added, subtracted, whatever, we've done everything we can. There's nothing else we can currently do to this.
now is when I worry about what I'm proving. This is the third step. Now I can stress about this. Normally with algebraic proof, it's some kind of factorizing though. This one's a bit harder because it's a square number, but normally it's like, if it's a multiple of 3, then you factorize out 3, for example. How do I prove it's a square number? Well, just see if you can factorize this generally. This is a full quadratic, so it should go into double brackets. So if we were to factorize that, do you see how I would get obviously n in both brackets? I'd obviously get plus in both. And then it needs to multiply to make 1, but add to make 2. Well, that's obviously 1 and 1. Hopefully now you can kind of see where the square number is coming from, because n plus 1 multiplied by n plus 1 is the same number multiplied by the same number, which is, in other words, n plus 1 squared. Now, why does that mean it's a square number? Well, it doesn't matter what n is. It doesn't matter that I've added 1 to it. It's basically saying you could substitute in any number that exists, add 1, but if I then square it, it has to be a square number, doesn't it? Any number squared is the square number. So that's why in terms of it works for any, prove it always is a square number. That would be your answer. I mean, you don't need to write anything else than that. That's just proven itself. This does represent a square number, doesn't it? So that's how I do it. It's just the starting point that I think is quite hard, figuring out where we're beginning. And this one was particularly hard because of this kind of triangular numbers, which was confusing. But beyond that, it's the same steps. Just apply, in this case, add them. And then at the end, try and factorize to see what you can prove. Okay, question 14. We've got OAB as a triangle, OBC is a sector of a circle centre O. Calculate the area of OBC, so calculate the area of the sector. So I know that the area of a sector is the area of the whole circle, pi r squared, multiplied by whatever angle, so that's like theta, whatever angle it is out of 360. That's what I know that formula. So that tells me, okay, I've got the angle, but do you see how I'm missing the radius? I would need to know that, wouldn't I? And the radius is this here and obviously this here. So does that then help you figure out, well, what do I need to use the triangle for? I need to use the triangle to work out OB as a side. So then you go, okay, well, how do I do that? We've got some sides, we've got some angles. It's going to be trig. It's not a right angle triangle, so it's not SOHCAHTOA. Therefore, I'm thinking sine or cosine rule. Okay, so this is how I'm kind of processing it in my head. Sine and cosine rule. Sine rule is pairs, isn't it? 2 angles, 2 sides. In this case, I don't want another angle. Cosine rule is 3 sides, 1 angle. Do you see how that would match? I know that obviously one of them is missing, but considering I want to find a side, that would make 3 sides and 1 angle. So I'm going to use cosine rule, which is obviously in your formula sheet. And because we want a side, it's already in the correct format, isn't it? A squared is equal to b squared plus c squared minus 2bc cos A. Now, luckily, I always do it based on the angle. So they said cos A, so the angle needs to be A. Luckily, it's already correct in terms of they put A there. If they didn't, you can always rewrite it. You can change the labels just to make sure it works for your formula. So if that's A, if I roll out this now, then obviously the one I want is side A, it's opposite. If this is angle B, then we can label that one B, and then I know that's O, but let's just pretend that that's C just to match our formula. So we want OB squared, and then we just sub it in, literally. 6 squared plus 9 squared minus 2 times 6 times 9 times cos 35. That's what I'm going to type into my calculator. Now, I actually write it a bit differently than that, but I'll show you. Get our calculator. So 6 squared plus 9 squared, that is fine, isn't it? Minus, and then what I do in the calculator just to make sure it's all correct is I put a bracket here and then just do 2 times 6. Oh, times 6 times 9. Oh my god, it's not wanting me to type it. Times cos, and it was cos 35, wasn't it? Yes. Obviously, make sure you close the bracket of the cos and then the bracket of the other one. And that's my answer. Now, just be careful though, because that is OB squared, isn't it? If you look at 9 and 6, 28 doesn't really match, does it? It's because it's squared. So if I were to square root that, again, just copy all of your answer, don't round it. Gives me 5.34. That makes more sense, doesn't it? If you look at the 6 and the 9, 5 is kind of in that scale. So OB, or the radius, is 5.34 ... 5.34 ... which is the same as the radius, isn't it? So now I can ignore the triangle. I'm done with the triangle, and now I'm moving on to just area of a sector. So I move up. We said earlier the area of a sector is pi r squared times angle over 360. So area pi times the radius squared. Now obviously I'm going to use the whole of the digits in my calculator, but I'll just write this for now. Times by the angle, which is 80 over 360. That's now the next thing for my calculator. So you see how I've still got this answer here. I'm going to keep that and use that with my answer button. So we're going to do pi times answer squared, that's the radius, isn't it? Times, and then 80 over 360. There. Now technically that's my answer. So now I'm at the point where I can actually round it. Do you see how it says give your answer correct to 3 significant figures? So that would be 9, the 1 is 1, 9 is 2, the other 9 is the third significant figure. And if I check the one after that, it's 1, so I round down. So 19.9. 19.9 would be the correct answer to 3 significant figures. Okay, so again, can you see how I'm not rounding any of my digits until right at the end if I can avoid it? That was 4 marks, that one. 19.9. Okay, question 15. This one's, I mean, only a few marks, but a little bit trickier. Hopefully part A you can recognise. This is really important to recognise, really important thing to know, especially for higher tier. Factorise a squared minus b squared. I hope that you can recognise what that is. That is difference 2 squares, because, well, the difference is the subtract. A squared is a square number, b squared is a square number, difference of 2 squares. And the way that we factorise difference of 2 squares is you do the double brackets, you square root both, so that would obviously be a and a, b and b. If it's an actual number, you square root the number, and then 1 is plus, 1's minus. Okay, that's why it's only 1 mark, because it's just something that we should have memorised. We should just know, I can see that, difference 2 squares. Now part B is where it gets a little bit trickier. Show that 2 to the power of 40 minus 1 is the product of 2 consecutive odd numbers, which is odd because this seems like algebraic proof again, but it's not really. Product means multiply. First of all, we need to know that. They haven't said hence or like therefore, but I feel like when I looked at this, I thought I can use my answer from part A to help me with part B, because this format is the same as this format. I know it's quite hard to see, but it is. And the product is obviously here, like that's the same thing, it's multiplying, isn't it? So the way I would show you this is, we kind of need to use index laws backwards. I want to split this into 2 numbers squared. Obviously that 1 is a square number anyway, isn't it? But the 2 to the power of 40, if I can use my index law, you know the third index law with the brackets, the one we saw in question 1a, I can split that up into 2 to the power of something squared. Well, I know that whatever I put here would be multiplied by 2, wouldn't it, to get 40. So do you see how this power here would be 20? I could split it into that. 2 to the power of 20 squared is the same as 2 to the power of 40. I think a lot of people would be thrown because 40 is not a square number itself, but index laws don't work like that, do they? You can just divide it. And then minus 1, which is the same as 1 squared, effectively, isn't it? Do you see how that's the same format? Hopefully you can kind of vaguely see that. Difference of 2 squares. So what I used when I did this is I factorised it like this. So that was like, the first term obviously is the square root, which is just 220, 2 to the power of 20, minus the square root of 1 is just 1, isn't it? Or, well, I put plus first. It doesn't really matter if it's minus or plus first. Then the same thing again, 2 to the power of 20 minus this time, the other one. That, if you were to expand it, would give you this. Now, the way that I proved that they were 2 consecutive odd numbers is I literally just, because this is a calculator, I just typed it into my calculator, as in each bracket separately. So, 2 to the power of 20, and then I put plus 1, is this, and they've said prove that it's 2 consecutive odd numbers. Well, luckily it's an odd number, so we've got, let me write this down, 1,048,577, And then that, which is the first bracket, isn't it, is multiplied, or the product, by the second bracket. So I go back, you can always just go backwards and then change that to a negative as subtract. Also an odd number. Do you see how that, if we're just looking at the last digits, 7 and 5, those are consecutive odd numbers, aren't they? 1,048,575. And I think that's enough to prove it. That's enough to prove it because the product is there, multiply, and they are consecutive odd numbers. Obviously, this one comes first, technically, but that's enough to prove it. But I think it's quite hard, this one, to recognise it's the same as part A. They haven't really hinted at that you should use part A. Okay, question 16, this is a nice one. So, on the grid, enlarge triangle T by scale factor -2 with centre enlargement -2, -2. So first of all, where's that? That's here. Make sure you obviously get that right. Draw that nicer. There. Now, scale factor -2, this is very much higher tier. They tend to use negative scale factors. Obviously, 2 as a scale factor is going to double it. Not only will it double the triangle size, but it will double the distance. You see this kind of like distance here. It will double that space. But the negative inverts it. So it's not just going to be like over here. And you can tell that because obviously there's no space. It's actually going to be upside down over here somewhere. So the way that I work it out, again, there's multiple ways to do this, but what I like to do is just count the squares. Some people like to draw lines. I personally don't like that method. That's just me though. So always count from the center to one of the corners. So let's do this top corner first. So from the center, I have to go 1, 2, 3, 4. Do you see how it's 4, but it's 4 to the left? So double that is 8. So that was 4 to the left. If I double that, it's 8, but because of the negative, I need to invert it. What's the opposite of left? Well, obviously right. So do you see how from this center, I'm going to count 8 to the right? 1, 2, 3, 4, 5, 6, 7, 8. That's where my new corner is going to be. This top corner is now over here. And then I do the, let's do this one next. So this one is 1, 2, 3 down, and then 3 to the left. So that's a bit harder because there's kind of 2 steps to it. I need to double both of these. Luckily, they'll both become 6, but I also need to change the direction. So this one that went 3 down, do you see how now that's going to go 6 up? So 1, 2, 3, 4, 5, 6 here. And then instead of 3 left, it's going to go 6 to the right. 1, 2, 3, 4, 5, 6 here. So that bottom corner is now there. You can kind of see my triangle is automatically doubling in size as well. And then the last one is obviously this corner here. You can obviously either count it from just the other corner, or you can count it from the center. It's up to you. So from the corner of this one, we went 2 to the left again. So double that is 4, but then it would be 4 to the right. So from this corner, 1, 2, 3, 4. And there. So if I now obviously draw in my triangle, do you see how it's inverted itself just naturally? It's got double the distance away from the center, and the actual triangle itself has naturally become twice as big. That's how I like to do it. As I said, you might like to draw the lines. I'll show you what I mean by that. You know, when you draw lines like through from your corners to the center and then carry it on. Some people like to do it this way, for example. I don't know. I find this kind of complicated myself. It's up to personal preference, really. It's just whatever you prefer to do. You can do it that way, or you can do it by counting. Completely your choice. They haven't told us to label it, so that's fine. Sometimes they do. Okay, question 17. Here is a distance time graph. Find an estimate for the gradient of the graph at t 2.5 or time 2.5 seconds. Obviously show how you get your answer. So this is one you just have to memorize. Gradient is a rate of change, isn't it? So I think, because I feel like a lot of people go, oh, it's just the 2 divided, like where's 2.5 here? This is 2.5. They would go here and just do like 20 or whatever it is, 21 divided by 2.5. It's not that, because there's no change there, is it? You've only got a single set of coordinates. So in this case, you have to draw a tangent. Okay.
So the thing is obviously, that's obviously why it's an estimate as well, but also everyone else's tangent will look slightly different. So I'm also going to get the mark scheme so you can see, because they'll give a range of possible answers as well. Let's just quickly have a look. So what you need to do is draw a tangent, so a straight line, at the point where they want. So obviously 2.5 goes up to here. So as best you can, try and draw a tangent. So if you think about a circle, you know, a tangent is where it's a straight line that kind of comes along and just touches, just skims the line, the curve in this case. So let's see how well I can do it here. Obviously with a piece of paper and a pencil, much easier. Just that. Something like that. Do you see how it's just skimming roughly at the 2.5 mark? You can obviously draw it longer than that if you want. You can extend it. Let's maybe extend that further. Maybe do it the whole of the grid. It's up to you. Like this, for example, extend it. But do you see how it's just touching at that 2.5 point on the curve? And then you're going to find two sets of coordinates from the straight line, effectively finding the gradient of a straight line from here. Don't rub this out. They want to see this in the mark scheme as well. I normally use the coordinates that is the 2.5. So, for example, that is 2.5. And then on my y-axis, when I looked at it, I had it on a piece of paper. When I looked at it, it looked roughly about 21, because you see how the scale is 1 square is equal to 2. So I did roughly about 21. And then I picked another. The other one that I picked was, you see this one here on 3? That was almost exactly 330. So just pick 2 on your line, any 2 coordinates that you think you can read off fairly well. And obviously then the gradient, if I move this up, is gradient of a straight line is change in y over change in x, isn't it? So m is the gradient. Change in y, change in x. So it doesn't matter which one you put first, as long as you keep it the same. So what I mean by that is, let's say I normally put the biggest one, so 30 minus 21, and then underneath I would therefore have to put, you see how the 3 and the 30 were from the same coordinates? I'd have to put the 3 there, and the minus 2.5. Okay, don't like mix them up like that. Try and keep them the same coordinates vertically, okay? So you can obviously type that straight into your calculator if you want, but that's effectively 9 over 0.5, so that's what I'm going to look up. Where's my calculator? Here it is. 9 divided by 0.5, or if you've typed in that whole thing, that's also fine. That gives me 18. Now, obviously, as I said, this one, they'll give you a range of answers. So when I look at the mark scheme, they've said that, obviously, mark 1 is for drawing a tangent in the correct point, so at the 2.5. Mark 2 is then obviously for your method to find the gradient, and mark 3 is for your answer, which should be within, they've said, 16.5 to 19.5. So as long as you've got something in between those two numbers, then you'll be fine. Then we've also got a part B here. What does the gradient of the graph represent? Remember, it was a distance time graph. So the gradient, in this case, you can either write the word speed, and that's easier, distance, speed, time, or you can also technically write velocity. They'll allow that as well. I think speed is probably more obvious though. Again, it doesn't even need to be a full sentence. You don't even need to write the whole 2 lines here. They've literally put on the mark scheme the word speed, so that would be fine. Okay, I'm getting into some of the harder questions now. Question 18. We have got a solid frustrum is made by removing a small cone from a large cone. So that's literally what, if you're not sure what a frustrum is, it's this shape here. So like if you had a cone and you chopped the top off. So as shown in the diagram, they've obviously then given us a formula here. The slant height of the small cone is 6 centimeters. The slant height of the large cone is 10 centimeters. And then the radius of the base of the large cone is 3 centimeters, which you can see obviously drawn there. Calculate the total surface area of the frustrum. So surface area, this is where sometimes
it can be confusing what's volume, what's surface area. Surface area is all of the surfaces added together. So you're just working out area and adding them all together. So for example, to see how in this terms of the frustrum, we've got a circle here. So I'd work out that area. There's a circle at the top. I'd have to work out that area. And then this whole curved thing all the way around, if you were to unwrap it and lay it flat, would also have an area. So I've got 3 areas I need to add together. Now, the easiest thing to do, if you're not sure about the curve or anything else, the easiest thing is to work out the area of the base, isn't it? Because we have that information. So the area, how do I label this? So let's call it big circle, just so you remember what I'm referring to. Circle. Oh, it's not letting me type it. Circle. There we go. You can actually read that now. Obviously, circles pi r squared. Pi times 3 squared, which I'm just going to leave for now. I know it's not even non-calculated, but I'm just going to leave it as 9 pi because then I don't have to worry about any decimals until the end. So that's the base. Leave that there for now. Then you might be thinking, well, let me work out the area of the top cone, of the top circle. But it's not obviously the same radius, is it? You can see it's a smaller circle. And then you're thinking, well, I don't have that radius. So this is actually something, I feel like you might not know this until you've been shown. Think about similar shapes. You know when you work out similar shapes and you have to work out a scale factor and all that? Basically, the cone at the top, the small cone, is similar, mathematically similar to the bigger cone. It's just the small cone but multiplied by a scale factor, isn't it? So that's why they've given us 6 and 10 as well. Those are the pairs of numbers that relate to the same measurement, as in the slant height. They both relate to the slant height, don't they? So I can compare those. So to find a scale factor, you can divide them in whichever direction you want, as in 6 divided by 10, 10 divided by 6, doesn't really matter. I'm going to do the small divided by the big, just as I think it makes sense in this case. You can do either, as I said. So the scale factor is 6 over 10 or 3/5 or 0.6, whatever you want to call it. So we're saying that the small cone is like 60% the size of the big cone. So therefore, that would also relate to the radius. So the radius of the small circle is the big circle radius multiplied by my scale factor. If you did it the other way, let's say you did it this way, 10 over 6, which is fine, you would have to divide. Okay, so just double check which way around you've done it. Because obviously we want our answer to be smaller. The radius of the small circle must be smaller than 3 centimeters. So it's effectively saying 60% of 3 over 10. You can either leave it as 9 over 5 if you want, or it's 1.8. It's not too much of a difficult decimal. So the radius here is 1.8. So you just have to know that they are mathematically similar and you can kind of scale it. That's fine. So now we know that, we can obviously work out the area of the small circle, can't we? That's fine. So the area of the small, and then let me write circle again. Yep. Is pi r squared again, but pi times 1.8 squared, which you obviously need the calculator for, so 1.8 squared. I'm going to leave it in terms of pi again. You can either write a fraction or there's not too many decimals there, so 3.24 pi. I'm just going to leave it like that. Again, we're not at the end yet, so I'm not rounding anything. Okay, I'm just highlight those because we need both of those, don't we? We need this one and we need this one. Now the last thing, we said we need 3 things to add together, is then obviously the curved surface area, which is why we've got this formula here. So the curved surface area of a cone is pi times radius times the length, which is this like slant height effectively. So what we need to do in order to find this frustrum is kind of the same as they said at the top. They said it's made by removing a small cone from a large cone. So to find the curved surface area of the frustrum, I need to find the curved surface area of the whole cone, the big cone, the curved surface area of the small cone, and then subtract them. Let me write it up here. So surface area, big cone. Well, that's sort of the curved bit, you know that, I'm not including the circle, is pi times the radius. So the radius of the big cone is 3, and the height of the big cone, or the L bit, is 10. So I would just literally leave that as 30 pi. And then the surface area of the smaller cone at the top is pi, again, times by that radius, which is 1.8, so we needed that as well, times by 6. That one I'm going to work out my calculator. 1.8 times 6 is 10.8, so that's 10.8 pi. And then do you see how we just said I just need to subtract this bit, don't I? So I'm going to take those away. So it's effectively 30 minus 10.8, and then we stick the pi on at the end. So 19.2 pi. 19.2 pi. That's our third bit, isn't it? That's the curved surface area of just the frustrum. So there's a lot there. There's a lot of working. You almost forget what the whole point of the question was. Now we need to add those together. So the total surface area of the frustrum is 9 pi plus 3.24 pi. 24 pi plus 19.2 pi. Now I can add all of that together. So 9 plus 3.24, obviously not rounding anything, using all of the decimals. So it would be 31.44 pi. Now obviously they want it in terms of significant figures, so that means decimal. So I'm going to apply the pi, and that's my actual decimal answer. So 3 significant figures, 98.7 is the 3 significant figures, but the next number is a 7 as well, so that would round up to 98.8. So again, you see how I'm just trying to leave all the rounding until right at the end so I don't end up making mistakes because of the rounding errors. 98.8 centimeters squared is your answer. And that was 5 marks, obviously. There was a lot to do there. Okay, question 19. Sana needs to draw the graph of y equals 3 to the power of x for the range 0 to 4 on the x-axis. So that's an exponential graph, isn't it? It's one of those ones you need to memorize what it looks like. She draws the graph shown on the grid. I don't know if you can see that, but it says write down. Oh, what's that? Write down one thing Sana has done wrong. 1 mark. Again, don't need to fill out all 3 lines, but just something really basic. If we know our exponential graphs, which we should, really dodgy drawing, but they always, doesn't matter what the number is, in this case it's 3, it doesn't really matter that it's 3. Anything to the power of x will always go through the y-axis at 1. Because that's where x is 0, isn't it? Any number to the power of 0 is 1. Any number, so like in this case 3 to the power of 0 is 1. It could be 25 to the power of 0. All of it's 1, so it should always go through. And you see, if you have a look here, they've drawn it going through 0, 0. So that's the thing that's wrong. So there's different ways to write that, but I would probably write it as should cross the y-axis, or some, any kind of way of writing this same thing is fine. It doesn't have to be specifically like this. Should cross the y-axis at 0, 1. Or you could say, well, that's kind of correcting it, but you could say she has crossed the y-axis at 0, 0, which is what is wrong. Should cross through at 0, 1. Anything to do with that, that's the key thing that's wrong here. I think they also allowed you to say it shouldn't intercept the x-axis. I think they also allowed that, but any version of that, this is the key point that we're focusing on, is this thing down here. Okay, it's an easy 1 mark. Question 20. Prove algebraically that 0.1 and then 2, 3 recurring can be written as 61 over 495. Now this is a really nice one if you just memorize the method. Really nice. So I always start with let x equal to whatever that decimal is they've given you. It's always the same method every time, but you do have to kind of figure out what combinations you need. So x, 10x, 100x, 1000x, that's the bit you do need to figure out depending on the number. So in this case, you see how the 1 is not recurring. So I want to get that out of my decimal. I want the decimal section to just be the recurring digits. So to move that out, I'd have to multiply by 10, wouldn't I? So obviously x times 10 is 10, x, and then this would be 1.23 recurring, so that I've isolated the recurring section. But you need two of those, two equations. Now, I can't just multiply by 10 again, because you see how that would be 12.32 recurring if I multiply by 10 again? That's not the same decimal. It has to be in the same order. So I actually need to multiply by another 100. So obviously 10 times 100 is 1000x. And then you're just moving the decimal place twice more. So that would be 123.23. So do you see how I've got two versions? So ignore the x now. Two versions, two equations with the same exact recurring decimal. The reason why is because I want to eliminate that recurring decimal. Obviously fractions don't have decimals in them. So then we're going to subtract them. So you might want to write it the other way around if you want, because obviously you don't want necessarily to have a negative. I'm just going to flip them the other way around, just so you can see. There, and then what was it? 10x is, I'm going to write it in the same units there, same scale. So subtract both. You always subtract the fraction, the equations. So that's 990x. This is effectively a non-calculator, really. And then when I subtract these, you see how obviously, because it's got the same exact decimals, all of the recurring part will cancel. That's kind of the whole point. And then it's just 123 minus 1, which is 122. Then we want to solve the equation for x. Obviously, I need to divide by 990. And then what we can do, because this is a calculator, is put that in a calculator, and hopefully it will simplify to the same thing that we've got there. I mean, you could probably see it's, obviously if you just divide it by 2, you could just do that, but if you want to check it in the calculator, that's fine. Yep, 61 over 495. So if I write that again, 61 over 495. And do you see how if we originally said that x must equal to the decimal, and now we've worked out that x equals also to this fraction, then obviously they are the same thing, aren't they? The decimal and the fraction. So that's it for that one. It's just, yeah, same method every time, just figure out which x's you need, 10, 100, 1000, whatever. Question 21, solving algebraic fractions. This is another nice one. So I obviously don't want fractions. The way that I do it is I just multiply across by the denominators to cancel them out. So you can do it in one step. I'll just do it in two just to show you. First of all, if I multiply across by x plus 4, I have to multiply everything in the equation by x plus 4. So obviously if I multiply by x plus 4, you see how it would cancel out that denominator. I would be left with 1. But I do need to multiply this second fraction by x plus 4 because it's a separate term. So that would just go in the numerator. 3 brackets x plus 4 over 2 minus 2x is equal to, and obviously on the other side, x plus 4. Then I would do the same with the 2 minus 2x. So obviously I have to multiply this 1 because that's a separate term, so that would be 2 minus 2x. In terms of this fraction, it would just cancel out the denominator, that's the whole point. So we're left with 3 brackets x plus 4. And then on the other side, it's double brackets, isn't it? X plus 4, 2 minus 2x. So I've got rid of the fractions. Now, obviously the next thing is kind of not logically just expand and simplify everything. So 2 minus 2x plus 3x plus 12 on that side, and on the right it's obviously expanding double brackets. We've got, in the wrong order, but that's fine, 2x minus 2x squared, and then plus 8 minus, just be careful with all the negatives, 8x. Now, do you see how we're obviously ending up with a quadratic, as in the highest power of x is x squared, so that's a quadratic overall. The way that we solve quadratics is by getting everything onto one side, 0 on the other, but the way that I decide whether to move it to the left or the right is based on whether my x squared is positive or negative. Do you see how because it's negative currently on the right, I'm going to want to move it to the left because that will make it positive. So I'm going to move all the terms from the right to the left. That's, again, more so just a preference, really. So we might as well collect the like terms first, mightn't we? So we've got minus 2x plus 3x is just x, and then 2 plus 12 is 14. And then the other side, I'm going to put the negative 2x squared first, just so it's in order. Minus 6x plus 8. Okay, and now I'm going to move all of those terms to the left. Because if I move the 2x squared, it's negative, I have to add it. Do you see how that becomes positive? You can also obviously just multiply through by -1, but I just prefer to move it. Add 6x, so that's 7x overall, and then minus 8, so that would be plus 6. Now I've got a nice quadratic there. They haven't mentioned in the question to give our answers in a certain number of decimal places or anything, so I'm going to assume that that means that I can actually factorize. If not, you can actually use the quadratic formula immediately now if you prefer. That's also fine, that's on your formula sheet. They don't mind how you solve it as long as you solve it, but naturally I kind of try to factorize unless the numbers are really difficult, which in this case they're not and they're all positive, so it's not too hard to factorize. So 2x and x, obviously 2x squared, it's obviously both positives. And then we're multiplying to make 6, adding to make 7. So I think, oh, not 4 there, we want 2 there to become 4 and then 3 here. Then we just solve it. So hopefully you should be happy with solving quadratics from here. You just look at each bracket separately equal to 0. So x would be minus 3 over 2 or 1.5 if you want to write it as a decimal, and x is minus 2. That's it, we've solved it. Those are your two solutions. Obviously we mentioned before, quadratics normally always have 2 answers. Okay, that's it. 4 marks for that one. Question 22, this one's kind of odd. I feel like looking through the past papers, I haven't really seen anything similar to this. So you might not necessarily know what to do with it, but I'm going to show you now. So given that the vector a, and then brackets 2, 6, plus b, brackets 8, 2, is parallel to the vector 13, 6, find an expression for a in terms of b. So the key thing here is parallel. What do we know about parallel vectors? Well, hopefully we should know that when two vectors are parallel, if you imagine 2 parallel lines, they're going kind of in this same direction, aren't they? But one is normally a multiple of the other. Obviously, one might be a bigger version of the other. So they're exactly the same vector, except one's a multiple of the other. You might have seen this if you've gone through vectors geometry, where they say prove parallel vectors. In this case, obviously, it's not laid out like that, but it's the same logic. So what I mean by that is we need to create an equation in the first place, because it says find an expression for b in terms of a. That's an equation. That's like a formula. So first of all, I want to relate all of this with this. So if I write down the a and the b bit as it is, plus b, what does that equal to? Now, it doesn't equal directly to 13, 6, because it says it's parallel. So they are the same in terms of the a and the b. The a and the b coefficients should be the same. How do I explain this? Like, it's quite hard without drawing anything. It's not exactly the same, because one is like, this could be a bigger version of this, or it could be a smaller version, but it is like the same if you were to draw straight lines. It's the same kind of, if you imagine it as an angle. It's the same like angle, isn't it? So I can't just write them equal. What I need is a scale factor, is what I'm trying to say. We need a scale factor, and we don't know what that scale factor is. So I'm just going to use k, you could use x, you can use whatever letter you want, but you need a letter. So then I can make it equal, because I know that they are equal just with this multiplication, with this multiple. Then I want to separate it into 2 equations, because we've got a and b. So as in, look at the top numbers and then the bottom. So for example, that would be 2a plus 8b, and then it equals to not just 13, but k13, oh well, 13k. And then the same with the second row. So 6a plus 2b is 6k. Now, we've effectively got simultaneous equations here. Obviously, we're not solving anything. We can't find b and a because we've got 3 letters and only 2 equations. So we can't solve anything,
But what we want to do is get rid of the k's, because obviously they've only asked for a and b. And in doing so, hopefully we can connect those two equations. So think about simultaneous equations, linear ones. When you're trying to eliminate, you could use substitution method if you want. I normally tend to use elimination method. I want to get rid of k. So I need to make the k's the same number, which is unfortunate because the lowest common multiple of 13 and 6 is 78. So I need to multiply the first one by 6, and I need to multiply the second equation by 13. Okay, so we're changing both equations. So that one's 12a plus 48b is 78k. And then the second one is 78a plus 26b is 78k. Now, because the k's are the same, you can either same sign subtract them, or because they're just both in terms of they're equal to 78k, you can make the other two sides equal. So that's probably what I would just do here. Make them equal to each other. So 12a plus 48b is equal to 78a plus 26b, because obviously 78k is equal to 78k. Do you see how now I've got an equation with only a and b? That's what I'm aiming for. That was the whole point. So all I need to do now is the formatting. They said find an expression for b in terms of a. What that means is I need b to be the subject and everything else with the a's on the other side. So I'm going to move, let's collect the like terms. I'm going to move 26b across. So 48 minus 26 is 22b. And then in the same time, I'm going to move the 12a across. So 78 minus 12, 66a. Now they want it in terms of b, so I don't want 22b, I want just b. So divide by 22, do you see how that would give you 3a? As I said, we can't solve anything, we can't find the values for a and b because we don't have enough information, but they've just asked for an expression b in terms of a. So yeah, I think this one's quite tricky to kind of bring together all of your knowledge of vectors. It's quite a niche question, that one. Okay, I think we've only got two more left now. So a circle has equation x squared plus y squared is 25. The point P with coordinates -3, 4 lies on the circle. Alex says that the tangent to the circle at P crosses the x-axis at the point -8, 0. Is Alex correct? So this one, you don't have to draw it, but I kind of like to sketch it just so I can see what's going on. So if I draw some axes, obviously at GCSE the circles are always going through 0, 0. You can tell by that equation it's just x squared plus y squared. So if I draw my circle, grab a circle, shall we? Circle, yep. Try and, oh, I think it goes from the middle, doesn't it? Yes. So something like this. You can just sketch it yourself, it doesn't have to look nice. And then, because it's 25, I know that that's the radius squared, so the radius is 5, isn't it? So 5, it's minus 5. This is minus 5. And this is 5. So just so I can roughly plot more or less in the correct place where the P coordinates are. So that's -3, 4. So it's about here, roughly, isn't it? That's P. Draw that P better. And then they've said a tangent at P. So I'm going to draw a line at P. Grab my straight line again. There. That's our tangent. What Alex is saying is that this coordinate here is -8. That's what he's saying. We need to see if that's correct. So obviously get rid of that because we don't know that that's correct. We want to find out this coordinate here. So effectively what I would do is work out the equation of the tangent, which is a fairly straightforward thing to do. If you memorize the steps, it's always the same. And then we can deal with working out the coordinates at the end. So the equation of a tangent, what we have to do is obviously it's a straight line, isn't it? Straight lines are always based on this format, y equals mx plus c. So I need to work out the m, which is the gradient, and then the c, which is the y-intercept. So you always work out the gradient first, but you need obviously a change in y over change in x, don't you? We've seen that in another question recently. We need two sets of coordinates. Obviously in terms of this line, P, you can't use this set of coordinates, right? Because we're testing if that's correct or not, so don't use that set of coordinates. We know one set of coordinates for the line P, for the tangent, -3, 4. That is factual. We don't know any other coordinates. So what you have to do is work out the gradient of the radius, this line I've just drawn here, because technically we know that it always crosses through at 0, 0, and obviously the radius joins the tangent at minus 3, 4. So I'm going to find the gradient of the radius, that's mr, is the change in y, so 4 minus 0, divided by the change in x, minus 3 minus 0, which is obviously negative 4 over 3. Then, because if you think about circle theorems, you should know that the radius and a tangent is perpendicular, they're 90 degrees. So think about perpendicular lines. So the gradient of the tangent is the negative reciprocal. Now this is already negative, so that would become positive. Reciprocal means flip the fraction. And you can see the tangent has clearly got a positive gradient from our drawing. So we've got the gradient. So now we know it's y equals 3/4 x plus c. Now the last thing we need to know is the plus c, the y-intercept. What is this up here? We do that by just subbing in a set of coordinates that's on the line. So we know minus 3, 4 is on the line. So I can sub that in. So just make sure you get the right way around. Obviously y is 4/3 times by negative 3 plus c. Let's just multiply that. Obviously minus 3 times 3/4 should be negative 9 over 4. Yep, negative 9 over 4. And then I would add that, wouldn't I? Because it's a negative. I need to add that. So 9 over 4 plus the 4 on the other side. Oh, make sure you put the plus in there. Is you can either write it as 25 over 4 or technically 6.25. So my actual equation of the tangent is y is equal to 3/4 x plus 25 over 4. Okay, last bit now. Now I'm actually worrying about what he was talking about with his coordinates. So he was saying, does it cross through at minus 8? We can always test if there's a point on the line by subbing in one of the coordinates and finding out the other one. So technically, for example, we are trying to find out it crosses the x-axis, where it crosses the x-axis. That's where y is 0, isn't it? The x-axis, y is always 0. So if you were to sub in 0 here, and now if we solve this equation for x, if we end up with 8 as our answer, we know that he's correct. If we end up with anything that's not 8, we know he's incorrect. So that's the last bit, just solve this equation here. So I would move the 25 over 4 across, and then in my calculator I'm just going to divide 25 over 4, negative, by 3/4. So negative 25 over 4 divided by 3/4 is negative 25 over 3, which is, I mean, if it was 8, it would just give you negative 8, wouldn't it? It's obviously not negative 8. Negative 8.3 recurring. So x equals negative 25 over 3. So you go, is he correct? Well, obviously no, because that's not the same number as 8, is it? So I'd put therefore no, and maybe write the coordinates, just because he referred to it in coordinate format, didn't he? So therefore no. That's what I would do there. Just work out the equation of the tangent and then find the coordinates. 4 marks. Okay guys, we're on our last question now. So actually this question came up in, I think I've done another video on it, which will come out in a few weeks, on probability. So there is a total of y counters in a box. There are x pink counters and 5 blue counters in the box, and then the rest of the counters are green. So there's a lot to take in there. I like to kind of translate all the words into just algebra. So for example, I mean the total is y. Pink can be written as just x. Obviously the blue is 5. And then what I would do for green is I would kind of write an expression for that. Because if green is what's left over, it's the rest. That would be the total minus the pink minus the blue, wouldn't it? That's kind of an expression for green. So I tend to like to just translate words, like sentences, into just algebra. Then they've said that x to y is 1 to 3. So if you remember what x and y is, that was pink to the total is 1 to 3. So actually, we could translate that into x's, couldn't we? Let's hold on for that. I'll just hold on to that for a minute. Let's actually read the rest of the question. So, Frida takes at random 2 counters from the box. Okay, when it's something like this, you might have seen my other live videos. I always think probability tree because you've got 2 events. I'm going to pick a counter, event number 1, and then I'm going to pick another counter. That's like, I just draw a tree and then another one, isn't it? It's kind of like that. So I'm thinking this is the layout of a probability tree. They've said find in terms of x an expression for the probability that Frida takes 2 counters of the same colour. Give your answer as a fraction in this format. So before we even do a tree, you don't have to necessarily draw a tree, but I prefer to visualize it that way, so I will do. Do you see how they said find in terms of x and then your answer? Do you see how there's only x's there? I know there's A, B, C, D, and E, but those are obviously going to be numbers. X is the only letter there, but we've got a total as y and also green. So that's why we've been given this ratio, is to be able to convert y into something x. So I'm going to do that now before I even worry about my tree. So we've said pink to the total is 1 to 3. So if pink is x, do you see how the other side would be 3x? Like the total could be written as 3x instead of y. So where I put total as y, I can also write that as 3x. And then here, let's do the same with the green. That would be 3x minus x minus 5, which obviously we can collect the like terms, becomes 2x minus 5. So now everything is in terms of x, or the blue is obviously just a number. Okay, now let's set up our tree. So we've got 3 colours, so we need 3 branches each time. So this is kind of going to be quite a big tree, I think. Move that up a tiny bit, hopefully you can still see that. So I need enough space. 3 branches, right? So this is her first counter, isn't it? First counter. Pink, how do I write that as a probability? Well, there's x pink counters out of 3x total counters. That's the probability, isn't it? Now I know you could simplify that fraction, but I wouldn't. Just leave it as it is for now. Then we've got blue. Blue is 5 counters, so the number 5, again out of the total, 3x. And then the probability of picking green is our 2x minus 5 out of the 3x again. So that's the first column. Then we obviously need to do our second one. Now, this could get really messy if you start drawing 3 and 3 and 3. The reason why I'm not going to is because if we actually look at what they asked for, do you see how it said that Frida takes 2 counters of the same colour? So in terms of my tree, I don't need to draw all the possibilities. Let's say if she picks pink first, we want to know the probability that she picks pink again. We don't really care if it's a different colour after that, do we? So I'm only going to draw that branch for pink for the second counter, just because otherwise it's going to get really messy. Now, the other thing to take into consideration is Frida has taken 2 counters from the box. That implies to me that she hasn't... You know how sometimes they say we take one and then we replace it and then we take another? In this case, I think she's just taken 2. So when I pick the second counter, the first one is still out of the box. So my probabilities are all going to change. And that means that instead of being x pink counters in the box, there's now x minus 1, because following this line, she's obviously picked one pink one. And also, instead of there being 3x counters in the box, there's now 3x minus 1 counters left in the box, isn't there? So we also have to consider that. Then just do the same for blue. So if we've picked blue once, we've only got 4 blue counters left, and then obviously 3x minus 1 overall. And then green, if we picked one already, this one's kind of hard to get your head around. 2x minus 5, there would therefore be another one less, wouldn't there, of the green. So do you see how that would be 2x minus 6? And obviously 3x minus 1. That's my tree. So for Frida to get 2 counters of the same colour, you have to highlight all the options, don't you? It could be that she gets both pink. It could be that she gets both blue. Or the third option is it's both green. So when we work out probabilities with a probability tree, you always multiply between the branches, don't you? So for example, the probability of getting pink and pink, so both pink, would be x over 3x multiplied by x minus 1 over 3x minus 1 minus 1. That would be the probability of getting both pink, wouldn't it? But then there's also the chance that instead of both pinks, you could get both blue, which is 5 over 3x times 4 over 3x minus 1. And then, well, or the other option is you could get both green. Again, multiply those together. So 2x minus 5 over 3x multiply by 2x minus 6 over 3x minus 1. And then do you remember when, if you highlight multiple different possibilities on your tree, that's when you then add them up, because it's either pink and pink, or blue and blue, or green and green, and that's when we add them. So to get this expression, we basically need to add all of those together and simplify. So like I said, you don't need to draw the tree, but I feel like it helps to figure out what is going on with the context. Now I'm at the point where I can kind of ignore the context of probability and just think of it as algebra. I'll try and scroll this up. I'm going to write all of that down here. We've got x over 3x times x minus 1 over 3x minus 1. Okay, that's pink. Plus blue. 5 over 3x. Try and get all of the symbols in the right place. 4 over 3x minus 1. That's blue. And then finally, plus the green. 2x minus 5 over 3x times 2x minus 6 over 3x minus 1. And now I'm just going to expand all of that. I'm going to add it all up. The reason why I didn't simplify any of these fractions, well, at least that one, was because I want them to have all the same denominator, so that when I go to add them together, because obviously their answer was only one single fraction, it's already got the same denominator. So expand all of these, as in multiply these within the brackets, is x squared minus x over 3x. Oh no, if I expand that, that would be 9x squared. Expand the denominator as well. 9x squared minus 3x plus 20 over obviously the same. And then the last one is a double bracket, so that would be 4x squared minus 12x minus 10x, that'd be minus 22x, just kind of skipping ahead there, plus, that's double negative, plus 30. And now we're almost there. Because they all have the same denominator, which tends to happen with probability trees generally, I can just add the numerators, can't I? So you see I've got an x squared plus 4x squared, that's 5x squared. Collect the like terms. Minus x minus 22x is minus 23x. 20 plus 30 is 50. And the denominator is just as it is. And the last thing, you just check, can I simplify anything here? The way that we could simplify is if there was a common factor between all 5 terms. Common number, common letter. But do you see how there's nothing? There's nothing that all 5 terms share. So that is just the most simplified answer. And if I scroll back, you can have a look at what they wanted. So you can see kind of both of those. Do you see the format that they wanted? At the top, we have a full quadratic, and at the bottom, it was kind of just 2 parts of a quadratic, which is what we've got, isn't it? Again, don't worry about the pluses or minuses. Just because it says plus in the format doesn't mean yours has to say plus. So that is your final answer. 5 marks, obviously, for that one. That was a massive question. And yeah, that's the end of the paper. So thanks for watching this live, guys. If you want to ask any questions, please feel free to write them down in the comments. I'm also going to link a lot of the videos that I've done which relate to the questions or the topics that have come up in this paper. So if you feel like you want to practice any more of those or look into them into more detail, I will link those down below for you as well in the order that they show up in the paper. Otherwise, you can always have a look through my channel and maybe even just look at the higher tier playlist for any topics you want to look at. And also there are the other 2 lives have been uploaded as videos for paper 1 of this year, June 2023, and paper 2 as well, if you want to go back and have a look at those as well.